Bismillahirrahmanirrahim. Assalamualaikum. My name is Alif bin Amadin. I am from Kuj. For today videos, I will talk about experiment for energy losses in pipe and fittings. So this is our last lab on thermo fluid lab MBC 294. So this experiment is about fluid mechanics. So on slot 1, I will talk about objective, apparatus and procedure. So the objective of this experiment is to determine the losses in the pipe fittings related to flow rate. Number 2, to determine the loss coefficient related to velocity head. To compare the losses of energy head pipe losses in different configuration of pipe. So this is the apparatus that we will use on this experiment. So by the way, this is ODL, so I never touched this apparatus actually. So this is the picture of it from the lab sheet. So here we go. Number 1 is 45-degree elbow. Number 2 is contraction. Number 3 is enlargement. Number 4 is 90-degree elbow. And number 5 is water inlet connection. Number 6 is 90-degree short band. Number 7 is manometer bank. Number 8 is gate valve. Number 9 is different pressure gauge. So number 10 is 90-degree elbow. And number 11 is drain water connection. So if you can see here, there are a lot of different degree, which is 45, 90 and so on. And this is the pressure gauge, if you can see my cursor. And this is the gate valve that we will use. So here we go for the procedure. So number 1, place apparatus on bench, connect inlet pipe to bench supply and outlet pipe into volumetric tank. So we place apparatus on bench and then connect pipe to bench supply and outlet pipe. So this is, we place the apparatus first and then we connect the inlet pipe. So this is the inlet pipe here to bench water supply, and then the outlet pipe into volumetric tank. So volumetric tank is actually on the bottom side. So step 2, with the bench valve full closed and the discharge valve fully open, start up the pump supply from hydraulic bench. So with the bench valve fully closed, so we need to close the bench valve and then discharge the valve fully open, start up the pump supply from hydraulic bench. So that's it, we close it and then we discharge the valve open, start up, and then the pump supply from the hydraulic bench. So number 3 is slowly open the bench valve until it's fully open. So this is the bench valve, so it opens slowly. So because we don't want the water go through inside of manometer band fastly, so we want it to be slowly. Number 4, when the flow in the pipe is steady and there is no trap bubble, from to close the bench valve to reduce the flow to the maximum measurable flow rate. So when the flow pipe is steady, so there is no trap bubble. So every time the fluid in pipe is steady, so no trapped bubble. So start to, and then we need to start to close the bench valve like at the bottom. So and then to reduce the flow to the maximum measurable flow rate. So next, by using the bleed valve, adjust water level in the manometer board. So this is by using bleed valve, adjust the manometer board, and then retain a maximum reading on manometer with the maximum measurable flow rate. So note, a lower flow rate will reduce the water level, while higher flow rate will increase the water level. Next, number 6. Note, reading on manometer and measure the flow with the volumetric tank. So we need to reading on manometer, and then measure the flow rate with the volumetric tank. So this is volumetric tank, and this one is the manometer over here. So note the reading on manometer and measure the flow rate with the volumetric tank. So this is the volumetric tank here, so we need to take the reading on here. Next, repeat the experiment with different flow rates. The flow rates can be adjusted by utilizing the bench flow control valve. So by controlling the bench flow from the control valve, so we can adjust, so the flow rate can be adjusted, and then we need to repeat the experiment with different flow rates. Number 8, repeat step 6. Note reading on manometer and measure the flow rate with the volumetric tank So this is, so we need to repeat the step 6 until the step 7. So then we will go to the slot 2 here. On slot 2, so I will do on calculation on the drawing and doing table and also graph by using the Microsoft Excel. So here we go. So this is table from a lab sheet here. So it give volume, time, flow rate, and then this is the manometer reading. So this is the flow rate, velocity in small bore pipe V, velocity head, 90-degree elbow, and this is the differential piezometer head. So that's it. So this is the table of the data. So this is data that we get from the feature. So our lab is actually on ODL, so the data already been given. So this is the calculation of it. I will give around 1 minute to make sure that everybody can see before I do the calculation. So we have flow rate, velocity of small type there. So velocity head, differential piezometer head. So this is everything of it. So let's go on the calculation first. So we will go this one. So I will do some simple of calculation. So yeah, I already do it by myself, so I will show again. So first one is we take answer. So we need to find the flow rate. Flow rate here. So flow rate is Q, actually Q dot m cube over s. So this is, so Q equal to V over T. So our V is 0.04 before that, so T, first T is 16.18 second. V is, so this actually having given 0.004 meter cube. So inner and outer, this is diameter. So on inner diameter is 17 millimeter, and the outer is 20 millimeter. So here we go on Q. So we have 0.004 over with time is 16.18 second. So we got is 0.0000247 meter cube over second. So this is the flow rate. So velocity for formula is this is velocity in small type, small. So V equal to 4Q over Y D squared. So actually is 4 times with 0.0000247 times pi. So the diameter, we choose the inner diameter because it's for small. Inner diameter is 0.017 square. So we got is 1.088 meter per second. So this is for small. And another one is for velocity heat. Velocity heat here. Velocity heat. So the formula is V squared over 2G. So V squared is the velocity in small type of bear. So 1.088 squared over 2 times with gravitational speed. So we got is 0.06 the H2O. So this is for the velocity heat. I don't think that everybody can see it, but okay. I think I will do more on, I will explanation more. So the next one, so you check new. So the differential piezometer is actually the simple one. So we just wait. So we use this for 90-degree elbow. So the formula is different. H equal to H1 minus H2. So the H1 and H2 already been given, but we want it to be divided by 1000. So the formula will be like this, 1000 here. So the question is 360 minus with 310 over 1000. So we got is 0.05 the H2 So this is my part of calculation. But and also the alter elbow we will use the same, which is the data has been given, so we just use on, okay, example for 45 degree, so we h3 minus h4, so this is the simple one, and the same by divide by 1000. Save. So we back to my calculation here. So if you can see, so this is the flow rate here. So the time has been given, the volume has been given, the inner diameter has been given, and also the outer diameter. So we just put inside the formula. And this one is velocity in small type var. This is the velocity head, and this is, I told you about the differential of piezometer head. So the same calculation, which is h1 minus h2, h3 minus h4, and another one is sudden enlargement, h5 minus h6, sudden contraction, h7 minus h8, short band, same, h9 minus h10, and another one is 90 degree elbow, so h11 minus h10. So the data already have been given here, so we just use it wisely, which is this is the h1, h2, and then this is the h3, h4, and that's all. So I will do about the graph here. So here we go. So the volume is on the first part of operation. So first one is volume is 4, so we drag it all the same 4. So it's actually 4 P4, so equal A4 over 1000. General. So it's all the same here, 0.004. So the time has been given on the data, so I just fill it, just 16.18. What is 16.51? What is 17.85? And one is 19.95. So okay, so next is flow rate. So for flow rate formula is volume divided by time, so equal volume is B4, so we need to close bracket first. So here divide by the C for so we get 0.0002472, just drag it here, and then we just need to fill in the blank about this table here, so 360. So actually if drawing on this part, you can do faster by playback, so times 2 or times 3, 289, and the one is 272, so 242, 250, 265, so number 4, 243, 240, 232, 234, 209, 209, 210 210. So number 6 180 189 186. So this is the data, actually data number 1 on the view feature. 186 189 190 209 209 210 210. So 139 115 150 160 160. So 150 140 130 120. This is 99 110 120 139. So 220 226 230 230. So now is 188 190 190 195. So that's it on the call it on the millimeter reading, millimeter H2O here. So why we divide by 1000 is actually this is a millimeter, so we have to change up to the meter. So here we go. So the flow rate is actually the same as this one, so we just equal B4 over C4. Okay, here. And then the next is velocity in small bore pipe. Two times 4 times with 3 with A13 here, 13, and then we close up, and then we divide it by actually 3.142 times with 0.017. I'm not sure, but I cannot do the square out on square, so I just time with 0.017 here, and so it's the same value. So we enter it. So we got this velocity, so we put it up here. Then that's all. So if we go on velocity, this is the velocity head. So velocity head is the same. So chances will be, so we equal first P130 try again 2, then we close up here, and then over with 2 times 2 times 9.81 here. So so we got 0.604, so we put it here. So next is the formula that is actually the same as I told. It's specific on the, so which is e4. So the first one is e4 minus f4, and then we close it up and then divide by 1000. So we enter it and then we put it over here. So we got the value. So this one is the 45-degree elbow. So just we can see is G4 and also H4. So we equal to close G4 minus which H4. We close up and then we divide it by 1000. So we enter here. So side arrangement is actually e4 minus, I don't know, which is 1 2 3 4 5 6. So i3 side arrangement is i3 i4 minus with j4 divide by 1000. So we got 0.3 here. So sudden contraction is KL. So K4 over K4 goes up, K4 minus L4. So we close up that by 1000. So we enter it. This graph will take time, sure, because this is just the graph we just have to, so it really took time here. And another one is MN. So this is all the value. So we need to build a graph here. So I will do about 2 graphs and then I will show what actually I have done. So actually this graph I already done, just the table also. So here we go, and I will do about 2 graphs and then I will show what this other graph looks like. So we go on the first one, which is for the elbow. So we take some of the value. So we put insert, we put scatter. So I will choose this one. I think this one. This one much better. So we push. I don't want to this one. So we did first. So we go to insert. Okay, I will change the data here. So we select data. So we add. So series X, so we choose this one. On series X is the velocity heat, and the series Y is Enerdy degree elbow. Okay, so what I want is to be more beautiful. So we change chart type. So we go to the line, and we pick this one, and we put OK. So this is the, so we put legend, and then we put access title here. So we name it here is actually piezometer heat differential. so we copy, then we put this one plus with so we take hit, and then one is velocity hit. So this is velocity hit. So I think this is for the first graph, and then we create another one. So we put insert, so we choose line. Actually we want to create one, so we just set line here. So we select data, so we add is wrong chart, so we can't do it directly, so we put scatter, we select data, we add here, so choose here, I choose this one, so we okay, and then we edit, and then for the series X value we velocity hit, okay, and another one is the 45-degree elbow, so we put okay, and then okay, so we change chart type, so we put line here, we take this one, and then we okay, and this is the number 2, the graph for 45-degree elbow. So we put legend and axis style, so axis style is differential piezometer the hit. So the one is velocity. So then we change the graph here, put here bracket 45-degree elbow. So I think that's all for my video of the F4 here. So we'll be back to the PowerPoint. So here we go. So this is the graph that actually they already been doing here. So which is this all is the graph for 90-degree elbow. We can see here 45 elbow, sudden enlargement, sudden contraction graph, and then this is the short band, and another one is 90-degree elbow to so actually we use the same method for the graph. So on slot 3 is the conclusion, recommendation, and also application of the experiment. So the conclusion is the experiment successfully conducted. So we learn about the concept of the pipe losses, energy losses, and pipe fitting. We learn how to use the apparatus, and then we can follow the procedure. So next is the objective of the experiment will obtain. So that's it. You all know that the objective are to determine the pipe fittings related to the flow rate we got, determine the loss coefficient we also got. Another one is to compare the losses, energy heat losses, and different configuration by pipe. So we use on the graph. Next is the data and graph has been shown and calculate by using the Microsoft Excel. So that's correct. I actually do it on Microsoft Excel and also do some calculation before we put the input of the calculation on the Microsoft Excel. So we were able to understand the concept of the experiment and procedures of the experiment. So on the recommendation, so do the experiment 3 times to obtain the true value. Next is understand and then how to use the apparatus. Number 3 is be careful on reading while taking the data of the experiment. And number 4 is understand and remember the procedure of the experiment. So this is some example of pipe. So this is for actually a lot of in the building here, and also we use this on in industry and also this one. So by calculating the flow rate and energy loss, we can reduce some accident or injuries that might be happen, or maybe some broken things because we cannot control the flow rate. So I think that's all for my video for this application and also for this experiment 4. So this is my last lab. I hope you guys enjoyed this video and thank you very much.